Welcome. Welcome to the series of lectures Physics. In the last class, we discussed about contact forces, in which we were able to learn the concept behind the normal reaction force and the friction force. These two were the forces which comes in picture when two bodies are in contact to each other. In today's class, we shall see another form of contact forces, and we shall name it as attachment to bodies. Means two or more than two bodies are not directly in contact with each other, but they are in contact, they are attached actually with the help of something else, or not something, we shall call it कि bodies are connected through a string. Just like that, suppose this is a block A, here is block B, and they are connected with the help of this string. So the body A and B are not directly in physical contact, but they are connected through a string. Means we shall call it as indirect contact. A and B. There may be another object also, like we can say C. This is connected with the string, or A and C are connected with this string, but this string and this string are not same. They are different to each other. This is one string and this is another string. In the same way, we can have another block also which is connected to another string. So we can say it as string 1, string 2, string 3, ABC, now name it as D. So in this way, the block can be connected to each other. Another example could be, suppose this is a pulley. This is a pulley. The block is here, and the string going on this pulley, and in this way it is connected. This is block A, which is placed on a horizontal surface, and the block B is hanging. But if we see, this is the same string, single string is able to connect A and B both. Same string, this is same string, there is no change in string. So in this way, two or more than two bodies can be attached to each other, can be connected to each other. Here, for the connection, two bodies are not directly in physical contact, but still they are connected to each. So see what happens in this case and what we shall going to consider. So when we are talking about attachment to a body, we must have something through which the bodies will be connected, and this is a string. So now there will be two cases. A string can be massless. We shall consider the string is massless or not massless. means it has masses. So there will be two different scenarios. A string can have mass or not, or it can not have mass. But इसका मासलेस हो भी सकता है और नहीं भी हो सकता है. अगर मासलेस होगा, अगर कंसीडर करेंगे कि स्ट्रिंग मासलेस है, दूसरा क्या होगा, फर्स्ट सेकेंड क्या हो सकता है कि ये इनएक्सटेंसिबल हो सकता है. या एक्सटेंसिबल हो सकता है. अगर एक्सटेंसिबल है तो इसको हम कंसीडर नहीं करेंगे अपने डिस्कशन में. तो हम जो स्ट्रिंग की बात करेंगे, दैट स्ट्रिंग मस्ट बी इनएक्सटेंसिबल. मस्ट बी इनएक्सटेंसिबल. इनएक्सटेंसिबल कहने का मतलब क्या है कि यदि यह एक स्ट्रिंग है और इसकी लेंथ L है, तो इसकी लेंथ चेंज करने वाली नहीं है. ऐसा नहीं हो कि इफ वी अप्लाई फोर्सेज एंड इट बिकम्स मोर देन L. It cannot be more than L. So it inextensible means the length of the string always remains constant. Length always remains constant. Always remains constant. So there are different conditions. तो what किसी भी प्रॉब्लम के लिए जब हम डिस्कस करेंगे तो हम डिस्कस करेंगे उस बेसिस पे कि स्ट्रिंग जो है वह इनएक्सटेंसिबल है, मींस लेंथ ऑफ स्ट्रिंग जो है वह चेंज नहीं करने वाला है. तो यह एक स्ट्रिंग के सारे कनेक्ट हो सकती है. दूसरा कनेक्शन जो होगा वह हो सकता है स्प्रिंग के चलते. ये स्प्रिंग है और यहां पे कोई मास m है और यह किसी सरफेस से हैंग कर रहा है. करेक्ट. तो जैसे इस बॉडी को हम छोड़ेंगे, हैंग कर रहा है, तो यह फिगर कुछ इस तरीके से आएगा. यह मास कुछ m यहां पे आ जाएगा. देयर विल बी, बिकॉज इट इज एक्सटेंसिबल. स्प्रिंग है तो एक्सटेंसिबल ही होगा. एक कॉन्सेप्ट है, सपोज दिस वाज द लेंथ. अगर original length when the spring is not stretched, the length of the string is L, suppose, and now this has been displaced by a distance of x. So now the total length of this spring will be L plus x. Now we have to consider one quantity which we shall call a spring constant. A spring constant. Or we shall denote it as K. So what happens, इस बॉडी पे जो फोर्स आएगा वह फोर्स F ड्यू टू स्प्रिंग. फोर्स F is directly proportional to the length extended. This is extensible length X. So now the spring force F, if we remove the sign of proportionality by the equality, there will be a constant, proportionality constant, that is known as a spring constant. A spring constant. This is known as a spring constant. A spring constant और spring force पे हम लोग एक डिटेल डिस्कशन रखेंगे जब हम लोग आगे के चैप्टर पढ़ेंगे वर्क पावर एंड एनर्जी. अभी के लिए कि स्प्रिंग कितना फोर्स लगाता है और किस तरीके से किसी दूसरे ऑब्जेक्ट जो इससे हैंग कर रहा है या स्प्रिंग से कनेक्टेड है वह कितना फोर्स लगाएगा, तो हमको देखना पड़ेगा कि उसके ओरिजिनल लेंथ L से कितना एक्सटेंडेड लेंथ है. जो एक्सटेंडेड लेंथ है वह वह स्प्रिंग फोर्स के डायरेक्टली प्रोपोर्शनल होता है. और जब प्रोपोर्शनलिटी के साइन को हटा करके हम इक्वलिटी के साइन में चेंज करेंगे तो एक प्रोपोर्शनलिटी कांस्टेंट आएगा. जिस प्रोपोर्शनलिटी कांस्टेंट का वैल्यू एक्सपेरिमेंटली फाइंड आउट किया जाता है, तो उस प्रोपोर्शनलिटी कांस्टेंट को हम लोग K बोलेंगे. डिफरेंट स्प्रिंग के लिए या K का वैल्यू अलग अलग होगा, बट फॉर द सेम स्प्रिंग इन ऑल द केसेस स्प्रिंग कांस्टेंट will remain same. In this way we can find out the spring force. So now let us assume some more cases, because all these concepts will be helpful when we are going to solve some problems on force and motion, or when we shall be talking about Newton's laws of motion and different cases. These are the basic concepts that must be in our mind before solving the problems. So let's see some more cases. What happens? First case is, let's denote it. First one. What is first one? A string is inextensible. A string is inextensible. If a string is inextensible, tension will come to play in picture, and the value of tension at each and every point of this string will remain same. Doesn't matter how it is connected to the masses. At both the ends there could be different masses, but the force of tension throughout the string will remain same. So force of tension throughout the string remains same. Meaning that, suppose this is a surface, here is a block A, here is block B, it is connected via a string, and now suppose a force is acting on block B in this direction. So what happened? This force pulls B, and B is connected to A through this string, so A will also move in this direction. We can prove that also. So at each and every point of this string, the value of tension, we shall denote it force of tension by T in our discussion. So force of tension at each and every point of this string remains same. Whatever be the value, if tension is 10 Newton here, at each and every point, doesn't matter we are talking about this point, this point, this point, this point, this point or this point, at each and every point, धागा के स्ट्रिंग के किसी भी पॉइंट पे उस टेंशन का वैल्यू सेम रहने वाला है. करेक्ट? तो व्हाट हैपेंस, अगर हम P की बात करेंगे तो B पे एक फोर्स इधर F काम कर रहा है. करेक्ट? यहां मेरा B है, तो this string will apply the force of tension because it is connected through a string. The block B is connected through the string, so force of tension will be applied, and this force will be in this direction, that is T. In the same way, if we are talking about A, this is our B and this is our A. So now if we see, we are only drawing tension. So A is connected through this string at this point, so force of tension will be in this direction, and no other force in horizontal direction on this block A, so force of tension will be in this direction. So what we are trying to say, tension, if on A tension is T, so on B tension will also be T, means tension will remain same. Same magnitude of force will be applied on A and on B. Why? Because the string is inextensible. स्ट्रिंग का लेंथ चेंज नहीं कर रहा है. अब सपोज कीजिए कि यदि यह बी 5 मीटर आगे चला जाता है तो डेफिनेटली ए भी 5 मीटर आगे जाएगा और डेफिनेटली यह लेंथ जो है यह भी 5 मीटर आगे जाएगा. तो डिस्प्लेसमेंट जो है वह ए बी और स्ट्रिंग तीनों का क्या है, सेम है. अगर डिस्प्लेसमेंट सेम है ऑब्वियसली उस टाइम इंटरवल में वेलोसिटी भी सारों की सेम होगी और वेलोसिटी अगर ऑल द ऑब्जेक्ट की सेम है तो एक्सीलरेशन भी सेम है. तो इन दिस वे अगर एक्सीलरेशन सेम है तो डेफिनेटली फोर्सेस आर कांस्टेंट. करेक्ट. सो इन दिस वे वी आर एबल टू सी द फर्स्ट कंडीशन व्हेन a string is inextensible. Now see what happens. In the other case we shall consider the masses of a string also. A string is what we are trying to learn. A string is massless. A string is massless. If a string is massless, let's consider this figure. Here is pulley. Here is an object M. And now suppose this is connected with, this is MA, or let's consider the block A and this block B. What happens? There will be two sides, this one from the pulley and this one vertically from the pulley. There are two sides of pulley, we can say left side, right side, upward, downwards, anything we can understand. But if a string is massless, the force of tension will remain same. The force of tension will remain same. Correct? Fine. Also we have to consider that a string is massless and here pulley is frictionless. So what are these conditions? A string massless, pulley frictionless, or we can say smooth. Correct. Now suppose the same figure, pulley is connected, here block B is attached, here is block A. Now suppose a string is massless. A string is massless. The direction of tension will be in this. But here a string massless, but pulley not a smooth, or it is not frictionless. So what will happen? अगर यह स्मूथ नहीं है, फ्रिक्शनलेस नहीं है, तो टेंशन दोनों तरफ चेंज कर जाएगा, लेकिन दोनों तरफ जो टेंशन होगा वो थ्रू आउट द स्ट्रिंग सेम रहेगा. सॉरी, सपोज कीजिए कि सेम स्ट्रिंग है, उसको दो पार्ट में डिस्ट्रीब्यूट करके दो डिफरेंट स्ट्रिंग बना दिया गया है। इफ स्ट्रिंग चेंज कर जाता है, इफ स्ट्रिंग चेंजेस द वैल्यू ऑफ टेंशन विल चेंज, बट हियर द स्ट्रिंग इज सेम, but due to the friction it is treated as this is different string and this is different string. In this way we have to understand. But so what happens here, if it is T1, here if it is T1, this will also be T1. Here we are considering pulley. Here if in the upward direction it is T2, it will change, the T1 and T2 will be different, so this will also be T2. अब यहां से यहां तक इस स्ट्रिंग को हम एक स्ट्रिंग मानेंगे और यहां से यहां तक इस स्ट्रिंग को एक दूसरे स्ट्रिंग बोलेंगे। जिस किसी भी सरफेस पे स्ट्रिंग डायरेक्ट कांटेक्ट में आ गया, फिजिकल कांटेक्ट में आ गया और वहां फ्रिक्शन अवेलेबल है, स्मूथ नहीं है, मतलब फ्रिक्शन इज प्रेजेंट, तो उस पॉइंट के दोनों तरफ का स्ट्रिंग अलग अलग टाइप से बिहेव होगा। Although the string is same, but it is being treated like this is another string and this is another string. We shall think like this, these are two different strings, but still a string is massless. This is same string here, starting from here to here, this is same string, but as friction is available here due to the pulley, this length and this length will be treated as different. So the value of tension at each and every point in this side and the value of tension at each and every point on this side will be different to each other. If it is tension throughout this string, हमने बताया कि जब तक स्ट्रिंग का लेंथ सेम रहेगा, हर एक ईच एंड एवरी पॉइंट पे टेंशन सेम होगा, तो यह पूरे के पूरे पार्ट में टेंशन T1 होगा। इस ब्लॉक पे इस डायरेक्शन में लगेगा, पुली पे इस डायरेक्शन में लगेगा, यहाँ पुली पे इस डाउनवर्ड डायरेक्शन में लगेगा और यह ब्लॉक बी पे अपवर्ड डायरेक्शन में लगेगा। तो यहाँ पर जितने भी फोर्स लग रहे हैं ये सारी T1 होंगे एट ईच एंड एवरी पॉइंट, और हियर द वैल्यू ऑफ टेंशन विल बी T2. Another case, suppose, but at the standard of class 11-12, this case will not come in picture, but suppose what happens, let's discuss for the sake of our concept. A string मास है और पुली फ्रिक्शन अवेलेबल है, वहां मास भी है। अभी तक जितने केसेस हम लोगों ने डिस्कस किए हैं, द केस वह स्ट्रिंग मासलेस लेते हुए आए, यहां पे स्ट्रिंग में मास है और पुली भी फ्रिक्शन है, तो क्या होगा कि हर एक पॉइंट पे टेंशन का वैल्यू अलग होगा, T1, T2, here it is T3, here it is T4. Correct. So this part will not be discussed at 11-12 level, but all these are very important. This one and this one is very important. This one will also come rarely, where always we shall see in the problem, when we will be solving problems, we shall see that the pulley is smooth and the string is also massless and inextensible. It will be written in the question, the string is inextensible, string is massless, pulley is frictionless. So for most of the cases this thing will come in picture. So it should be in our mind when solving the problems. Actually इस पे सोचने की कोई जरूरत नहीं है, स्ट्रिंग सेम होनी चाहिए। जब तक स्ट्रिंग चेंज नहीं होगा, कंडीशन है कि मासलेस होना चाहिए और फ्रिक्शनलेस होना चाहिए। तो अगर स्ट्रिंग चेंज नहीं है, जब तक सेम स्ट्रिंग है, तब तक टेंशन का वैल्यू स्ट्रिंग के हर एक पॉइंट पे सेम रहने वाला है, वह चेंज नहीं करेगा। इस कॉन्सेप्ट को हम लोग सीखते हैं। तो इस तरीके से हम लोगों ने कॉन्टैक्ट फोर्सेस जो कल हम लोग डिस्कस किए थे, फोर्स ऑफ नॉर्मल रिएक्शन एंड फ्रिक्शन फोर्स, आज हम लोगों ने सीखा टेंशन का फोर्स, अटैचमेंट बॉडी में कैसे होता है, और स्प्रिंग का फोर्स. सो जस्ट रिकॉलिंग दैट, and now we shall see how we can draw what are the forces acting on a single body. What are the forces acting on a single body? There will be different kind of forces. So now sir, see, let's analyze some problems. What happens? I am giving you something. Suppose this is a surface. Here we have a bigger block A on which a small block B is placed. Correct. One thing, अगर किसी भी बॉडी में मास है तो आपको पता है ग्रेविटेशनल पुल नीचे की तरफ आता है, तो एक वेट का फोर्स तो लगेगा उसमें. बाकी हम ड्रॉ करते हैं, इस पे देखते हैं कौन कौन सा फोर्सेस लगने वाला है. तो अगर हम ए की बात करूं, ए, if we are talking about A, definitely it has mass, so weight of A will be in the downward direction. In the downward direction. कोई भी बॉडी पे वेट ऑलवेज डाउनवर्ड डायरेक्शन में होता है, वर्टिकली डाउनवर्ड डायरेक्शन में होता है. डिटेल्स में इस पे हम लोग डिस्कशन करेंगे. और इसका वैल्यू जो होता है वह मास ऑफ ए इंटू जी एक्सीलरेशन ड्यू टू ग्रेविटी के बराबर होता है. तो यह वेट काम करेगा इस पे डाउनवर्ड डायरेक्शन में. अब हम लोग वी हैव ऑलरेडी सीन दैट इफ द पार्टिकल इज प्लेस्ड ऑन ए सरफेस, द सरफेस विल exert a force of normal reaction. Exert a force of normal reaction. Correct. So it is, this is the common surface, so it will apply a force of normal reaction in this direction. This is due to, suppose S, so this is due to the surface NS. Correct. So if we draw A here, if we draw A, weight of A will be in downward direction and force of normal NS will be in upward direction. Correct. But this block A and B also shares this common surface. Correct. This is also a surface. So now B will exert a force of normal reaction perpendicular to its surface. Normal reaction का force always perpendicular होता है. तो B भी इस पे परपेंडिकुलर डायरेक्शन में एक फोर्स अप्लाई करेगा अपने सरफेस के परपेंडिकुलर. तो B अपने सरफेस के परपेंडिकुलर ये डाउनवर्ड डायरेक्शन में, ये डाउनवर्ड डायरेक्शन में एक फोर्स लगाएगा A पे. यह होगा N. किसके चलते? B के चलते. तो यहां पे एक फोर्स और आ जाएगा जिसको हम लोग बोलेंगे NB. तो A, block A in contact with two surfaces, the first one, and this is B, A and B common surface, so there will be two normal reaction of forces, NA, NS and NB, and will be applied on A. But when we are talking about B, what will happen? If we try to think how many forces are acting on B in this condition, so definitely it has weight. Body have weight, so there will be weight of B and always in vertically downward direction. But this B is in contact. B in contact with A only. Contact with this surface only. A was in contact with this surface and this surface. There were two surfaces. But for the B, it is in contact with single surface. So A will exert the force perpendicular. So for A, perpendicular we go in upward direction. So this will be an A. This will be an A. But remember, the force of normal reaction applied by A on B and the normal reaction force applied by B on A will be equal in magnitude but opposite in direction. For direction you see NB in downward direction and NA in upward direction. But here NA is equals to NB also. So means if we have a common surface, the forces in opposite direction, the force of normal reaction in opposite direction is equal to each other. तो फॉर बी के लिए अपवर्ड डायरेक्शन में नॉर्मल रिएक्शन है, तो ए जितना फोर्स बी पे लगाएगा बी उतना ही नॉर्मल रिएक्शन का फोर्स ए पे लगाएगा, बट डायरेक्शन क्या होगा, अलग अलग होगा. तो दो फोर्स इक्वल मैग्नीट्यूड का है और अपोजिट डायरेक्शन में काम कर रहा है, मतलब रिजल्टेंट क्या करना है, जीरो करना है. तो वी शैल राइट डाउन, वी शैल डिस्कस अ लॉट व्हेन we will be studying about Newton's laws of motion, Newton's second law of motion. There will be different kinds of problems there, and we shall be able to solve all kinds of problems. We shall discuss all kinds of problems. So it must be kept in mind. We can have another example. What we are discussing, the contact forces. Now suppose this is a surface, this is block A on which another block B, on which another block C. And now we have to think how forces are acting on A, B and C. This is simple. First consider A. Don't write block, just consider A. On A, what are the forces? A has weight, so WA weight will be in downward direction, and A in contact with B, so a normal reaction on B will be in downward direction. This will be N due to B, and this is also in contact. With A, so normal reaction due to this surface S, suppose this surface is L, will be in upward direction. यहाँ पे ये NS है अपना और ये B एंड ए का फोर्स लगाएगा, एन बी का फोर्स लगाएगा ए पे, वह डाउनवर्ड डायरेक्शन में लगाएगा. यह सरफेस, दिस सरफेस विल अप्लाई द फोर्स इन अपवर्ड डायरेक्शन एंड दिस सरफेस विल अप्लाई द फोर्स इन downward direction because it is in contact with two surfaces. This one is the first surface and this one is the second surface. In the same way, if we need to write for B, what we shall write? B has the mass, so there will be weight on B. B in contact with this surface, so A will apply the force of normal reaction and perpendicular to it, so in NA direction, upward direction, इस surface पे perpendicular ऊपर की तरफ होगा जब A अप्लाई करेगा. जब B अप्लाई किया था तो नीचे की तरफ था, इसीलिए यहाँ पे नीचे की तरफ दिया गया, या NA ऊपर की तरफ होगा. This is for the first surface. इस surface की यदि मैं बात करूँ, if we are talking about this surface, तो B is also in contact with C. So C will also apply the force of normal reaction, but C will press this body. इस surface पे C के चलते normal reaction downward direction में होगा और this will be NC. But NA and NB will be equal to each other. NA and NB will be equal to each other. Now we are talking about C. If we are talking about C, weight of C will be in downward direction. And C has a single common surface, this one. So this will be applied. This will be applied in upward direction. So what will be here? NB. NB in the upward direction. On C there will be two forces only. One due to weight in downward direction and one normal reaction due to B in upward direction. And here if we see NB, the force of normal reaction, and NC will be equal to each other. NB and NC will be equal to each other. यह एक दूसरे को कैंसिल करेगा. यहाँ पे जो नॉर्मल फोर्स B और B पे A, नॉर्मल फोर्स A, this one in upward direction. In this surface it is in downward direction. In this surface it has single surface, common surface, so it will apply the force in upward direction. So what we are trying to do here, we are trying to draw the picture. We are trying to draw the picture that shows the direction of forces. We shall calculate the magnitude of forces by the equations. Here we shall trying to learn how the forces will be acting on each and every particle. See, another example, note it down. You can consider it. Now suppose this kind of picture. Suppose this is a ball and this is placed in this way. It has mass m. So this is in contact with them. So here one contact surface is this, another contact surface is this. Correct. So what will happen? Mass m is there, so weight will be in downward direction, and it is m, so it will be equal to m into g. We shall see. But what if we are talking about the force of normal reaction? This ball is in contact with this surface, so this surface will apply the force of normal reaction perpendicular to it. Suppose we are naming it as N1. This surface will also apply the force of normal reaction, but this will apply perpendicular to this, and we shall call it as N2. So these will be the forces acting on this mass M. Suppose we are writing this mass M here. This surface will apply perpendicular to its own. This surface will apply the force perpendicular to its surface. So when two particles are in contact, let's see what is the perpendicular to the surface. If it is in contact, the force of normal reaction will be perpendicular to it. So in this way, there will be lots of cases. So now, just see another example. Now suppose this is a surface. A pulley is attached to it. A mass A, block A is attached. This is connected with another pulley. This is connected with another pulley, where we have two masses. Let's suppose this is M1, this is M2, and this is M3. Three blocks are there. Now you have to think how forces are acting on these blocks. So for M3, when we shall be discussing, definitely weight M3 will be in downward direction. It is placed on this surface, so this surface will apply the force of normal reaction and 1 suppose, or M3. This is also W3. Let's suppose M3 means W3. M3 in upward direction, and this block is connected to this string, so this T1 will be applied, sorry, T3 will be applied in this direction. And now we can see that starting from here to here, the length, the string is a single string, so at each and every point the tension will be same. So on this pulley, there are two masses M1 and M2, so definitely here will also be a T3. Means throughout the string the value of tension will remain same. Throughout the string the value of tension will remain same. So if this is T3, this will also be T3. Why? Because two masses, pulley is massless. We shall write that a string and pulley are massless and स्मूथ. मासलेस भी है और स्मूथ भी है. तो जब तक स्ट्रिंग सेम रहेगा, जब स्ट्रिंग चेंज करेगा टेंशन का वैल्यू चेंज कर जाएगा. क्योंकि स्ट्रिंग चेंज नहीं किया है, दिस पॉइंट टू दिस पॉइंट स्ट्रिंग इज सेम, सो ऑन दिस ब्लॉक दिस विल पुल by the T3 in this direction, and this pulley will be pulled in upward direction, so T3 will be in upward direction. But now suppose, what about M1? Weight 1 in the downward direction, and this tension T, suppose T in upward direction. Here there is no surface, so no concept of normal reaction force will be discussed. There will be no normal reaction force because this is not placed on a surface. This was placed on a surface, that's why we draw the force of normal reaction in upward direction. This is hanging body. This is hanging body. This is hanging body through a string. So this is not in contact with any surface, no normal reaction. So need not to be confused here. No normal reaction. This is connected through this string, but starting from here, going over the pulley to this block M2, the string is same. So at each and every point, string is same, massless and smooth. So at each and every point, tension will remain same. So on M1, tension in upward direction, and if it is T, so if we draw on M2, this will also be T, and force of weight force will be in downward direction. That is reality. किसी भी वस्तु पे जो weight होगा वो always downward direction में होगा by default, but tension ऊपर की तरफ होगा. करेक्ट. अब ये पूरे का पूरा सिस्टम की अगर मोशन को हम लोग डिस्कस करेंगे तो we shall discuss when we shall be studying Newton's laws of motion. But here what we are trying to do, we are trying to do some pictorial representation that shows the direction of forces. Direction of forces are very, very important. If there are so many forces acting on a single body, and if a single forces, we draw the direction wrongly, the whole problem will become wrong. It cannot be corrected. So it is very important to learn how we can draw the direction of forces and what equations can be written, that we shall learn later. Through the equation we can find out the value of magnitude. From here we can find out what is the value of T3, N3, W3, W1, WT. We can find out the value mathematically. But for direction, we have to draw the diagram, we have to draw the picture we have to make the pictorial representation of the blocks. So for having the pictorial representation, we have a name which is known as FBD, means free body diagram, means free body diagram. So what? This is pictorial representation of forces. This is pictorial representation of forces. Let me define this also for the sake of understanding. So if we are talking about FBD, means free body diagram, free body diagram. So for drawing FBD, or we can say or pictorial representation of all the forces acting on body we show, or what we can say, draw the direction of the forces acting on it externally. This is very important. Externally, what is very important? Because we shall not consider internal forces. If the forces are internal to each other, we shall not consider it. We shall consider external forces. What external agents are doing and what external forces are being applied on the particle, that will be the case of the discussion throughout the syllabus. So, how we can achieve this? For this, remember 2-3 points. Make or choose an isolated system. Isolated system. Then only you will be able to see what are the external agents that are acting on the body. For example, when we are talking about this block M, suppose this is isolated. This is isolated. We have to consider that. This is isolated. So when this is isolated, this surface will also become external. Gravity, Earth is also external for it. So the force due to Earth or gravitational force will be in downward direction, and the normal reaction force will be in upward direction. And what we have drawn is known as FBD. So आज पूरे के पूरे क्लास में हम लोग जो डिस्कस कर रहे थे वह क्या सीख रहे थे? FBD. इसमें हम लोगों ने फोर्सेस को भी डिस्कस किया, इसमें हम लोगों ने आइसोलेटेड सिस्टम के बारे में डिस्कशन किया और इसमें फोर्सेस के डायरेक्शन के बारे में डिस्कस किया. सो वी शैल स्टॉप हियर. वी लर्न कॉन्टैक्ट फोर्सेस इन डिटेल्स, हाउ कॉन्टैक्ट फोर्सेस act on a single isolated system or on a body, single body or combination of body. अगर हम 2 body को एक साथ लेंगे, that will be isolated and that will be considered as a single block, and the force, internal force between 1 and 2 will not be considered. We shall always consider the force that acts on the particle externally. So this word is very important. Externally, isolated system is very important. So just you have to think, we have to learn on which body we have to consider the forces. Take that body and think how many forces are being applied on this body that we have chosen. Suppose, for example, we have taken this pen. This pen is lying on my hand, and we are trying to discuss how many forces are acting on this pen. So just think this pen is isolated. This pen as an isolated system. And now think how many forces are acting on it. So this pen has mass, so there will be a force in downward direction, weight, and as it is lying on my hand, so there it is sharing a common surface with my hand, so my hand is external to it and it will apply forces in upward direction. So we have to think like this. We shall learning this concept because all these things will be used while solving the problems. When doing motion, we are discussing about the cause of motion. So when we shall be discussing it, all these concepts will be taken together or will be taken as a bundle, assembled way. एक साथ assembled way में इस problem को, इस concepts को हम लोग apply करेंगे when we will be solving some different kinds of some simple, some different kind of problems. There will be lots of problems on it. We shall be having more than 5 to 10 classes where we shall be devoting our time in solving the problems because it is very important, and this will help also to learn other chapters where all these concepts will be used. So keep remember the things, keep practicing the things, keep learning. Thank you for attending the class. Thank you very much. See you all tomorrow in the next lecture. Thank you.